Thank you so much for this opportunity to share with you our research that we have been conducting over the past few years. I'd also like to introduce Christina Camilleri, who's my research assistant. She's a graduate from Franciscan University in biology and has volunteered in the lab and is now a paid research assistant in the lab, assisting me with the research that I'm conducting. As we go forward, there's a couple of things I would like to ask you, please, to do. First and foremost, I'm going to be talking about animal models. But as we go forward, to a certain extent, I want you to forget that it's an animal that I'm talking about. I want you to keep in mind, actually, the presentations that you all have heard in the past couple of days, because that's what goes through my mind as I'm presenting it to you. If we truly believe that faith and reason are two wings that basically bring us towards our Creator, then there is no contradiction between what we observe in physiology and what we believe. And that is a sincere conviction that I have had, and that's what keeps me doing the research that I'm doing. The reason I investigate animal models is because they provide us with a basis of investigating questions in a more objective, isolated environment, free of social norms, politics, religion. We don't have those influences in the rats. I'm going to be talking to you about rats. I work at Franciscan University. I can assure you they are neither catechized nor baptized. So what you are observing here are purely physiological effects of what I'm about to describe to you. So as we go forward, like I said, please keep in mind the talks that you've had from all of the great speakers that we have had here. Keep in mind of how this applies and into what's going on and what's being observed. So this is the presentation outline here, and I'm going to basically give you the background and the rationale of our study. We're going to talk about the results. Christina will outline the behavior aspect. I'm going to give you an explanation and the implications of these results. What do they mean? What should they mean to you as physicians? The relevance to humans, and also the future direction. With regards to abortion, I don't need to be telling you this. You're all familiar with the methodology of abortion, chemical or surgical. The abortion is also identified by the time in gestation that it takes place, early term, mid-term, late term. I included post-birth there, and the unfortunate direction that we're going does not really have anything to do with my presentation, but you're seeing it in the literature being referred to as post-birth abortion, which realistically is infanticide. So this is abortion, and the definition of abortion and how it's done. The consequences of abortion. We hear about them a lot. We see them debated. We see people arguing about this. So it's a widely debated topic. The consequences include, but are not limited to, mood disorders, anxiety, substance abuse, suicide, depression-like behavior. However, unfortunately, there is a lack of objective physiological data that tells us, well, this is what's happening at the physiological level. Interestingly, the manufacturer from which I purchased the drugs, I use the same chemicals that are utilized in humans for the induction of the chemical termination. The manufacturer that I purchased the medication, the drugs from, has this warning on it. Notice the first warning: may damage fertility or the unborn child. I find that quite interesting, so somebody realistically does know that it's a child in the womb. So the rationale. Pregnancy is a physiological process, is a normal physiological process. This involves significant physical and physiological changes and adaptations that allow the female to be able to carry the pregnancy through full term. This involves, among other things, significant changes in the hypothalamic pituitary adrenal axis, the HPA axis, so much easier to say, that influences everything. Hormones, immune system, neurotransmitters, and ultimately affects behavior. These aspects, how it affects behavior and the impact of that, can be also investigated in animals, because the neurocircuitry and the physiology in that regard is very similar, if not the same in many cases. So in animals, we can address the physiological effects, because if pregnancy is a normal physiological process, if we terminate a pregnancy that is viable, and given all of these changes that are taking place, we can't expect the body not to react. We can measure the changes and the consequences of this physiologically. In rats, we can use oxidative balance, electrophysiological, electrochemical measurements in the brain. Keeping in mind, and I want to bring this up now for you to keep it for later on, the fact that when we're talking about psychiatric disorders, you can summarize psychiatric disorders in one sentence: an imbalance between the upper brain and the lower brain. And we can measure the communication that takes place between the upper brain and the lower brain in situations of psychopathology. We do it for schizophrenia and animal models of schizophrenia, animal models of Parkinson's disease, and this information informs us as to potentially what is going on in the humans. That's how drugs are developed. The subjects and the experimental groups. All experimental procedures meet the NIH guidelines for the care and use of the lab animals. The protocols were approved by the Institutional Animal Care and Use Committee. The animals that we use are female Longevens rats. They're single-housed at 9 weeks, 12-hour light dark cycle. This is standard for animals. They're controlled temperature and humidity, and free access to food and water. The N is 81 rats, 19 to 21 rats per group. And the groups are, starting bottom right, D minus, P minus. This is the drug, this is the total control, the true control. These rats receive vehicle and are not bred, are not pregnant. Right above it is D plus, P minus. This is the group that receives the drug but is not bred. This is the control for the effects of the drug on its own. Bottom left, the D minus, P plus. This is the pregnant group, the group that is bred, becomes pregnant, receives vehicle, therefore keeps the pregnancy. The D plus P plus group, on the other hand, is the group that is bred, is pregnant, receives drug, has the abortion. D plus P plus group, therefore, is the abortion group. Rat gestation is 21 to 23 days. The drugs that we use are exactly the same as what is utilized in humans. Mifepristone, misoprostol, 50 milligrams per kilogram and 0.3 milligrams per kilogram respectively, and this is intragastrically. The dosing for this, the dosing was kind of difficult to come by because there aren't any experiments that were investigating what we are. The doses were initially based on a paper by He et al. in 2003. However, they utilized 1 milligram per kilogram of mifepristone and said in their paper that they had 100% abortion rates. We tried that and we got nothing. So further research and then utilizing the human equivalent dose equation backwards, looking at Planned Parenthood sites, seeing what they give to humans when it comes to these drugs, and working backwards in order to see what an animal should be given, we calculated and came up with the doses that we ultimately utilized. The drug administration takes place on day 12, 13, and 14. Mifepristone is administered on all 3 days. On the third day, the addition of misoprostol is administered 2 hours after the last dose of mifepristone. Rats in the control groups are being treated in exactly the same way, except they receive vehicle. Okay? Behavior. The measures, the procedures that we conducted, the measures that we made. Body weight. Body weight is a measure of health and well-being. This is according to NIH standards. Okay? In humans, weight gain or loss tends to depend on the situation, in situations of stress. In rats, weight loss is generally reported under the effect of stress. Food intake or food weight. This is also a measure of health according to the NIH. In humans, changes in food intake tend to depend on the type of stressor. In animals, in the rats especially, the changes in food intake also depend on the stressor, but generally what we see is no effect if it's mild, or a decrease in food intake if the effect is moderate to severe. We also measure vaginal impedance. We breed our own rats, raise our own rats. We ensure that there is no inbreeding, so we maintain a healthy, very healthy colony. Vaginal impedance is measured on a daily basis, and this is a way of getting an indicator of where the rats are at in their estrous cycle. The peaks indicate fertile phases, and this is when we breed the rats. Estrus in animals is the equivalent of ovulation in humans, and there's increased sexual receptivity. Typical graph looks like this. So rat cycle is about 4 to 5 days. So each of these is a rat cycle. And then on this last cycle here, we actually bred the rat, and you see that there are no peaks through the pregnancy. Sucrose consumption preference. This is utilized in animal models in situations of stress, where if we see a decrease, it's taken to be an indicator of anhedonia. Now, as I'm mentioning this, I want you to keep in mind the DSM-5 criteria with regards to the diagnosis of depression. So this anhedonia, the anhedonia model, is meant to mimic or to represent what the DSM-5 is telling us with regards to what we expect to see in situations of depression. Locomotor activity. This is a measure of exploratory behavior. In our case, we measure it using rearings, when the rat stands on its hind legs, distance traveled, overall speed, time spent in cage corners. Humans and rats, we see a variety of effects when it comes to locomotor activity in the situations of stress or depression. But this here also is a parameter that we relate to the DSM-5 criteria for the diagnosis of severe depression related to reduced physical activity, physical movement in depression. The images, the bottom one on the right is typical activity during the period of measurement. The X's, the red X's, those are points of rearing, and that's the part of the cage that is towards the outside, so the rats are investigating the environment. The equipment is shown above. Home cage activity. Home cage activity, like the previous parameter, is used to basically look at the aspect of reduced physical movement in depression. We made this measurement objectively because we take care of our rats. And we had, all of us had actually observed that something was not right in their home cage. The rats that had the abortion were not behaving like the normal rats do. So we wanted an objective way of being able to actually measure this in order to be able to quantify it and actually speak about it properly without saying we feel. With regards to the forced swim test. The forced swim test, the mobility, so the rats put in a tube to swim. Rats are natural swimmers, they're not going to drown. The whole idea of the forced swim test is that a rat that is depressed, this is a kind of behavioral despair. A rat that is depressed is only going to swim enough to keep itself from drowning. Whereas a rat that is not depressed is going to swim around in order to try and escape. Okay, that's the whole logic behind it. It's a standard test that is used for preclinical testing of antidepressants, and there's various, in terms of effects, there's various effects that have been reported depending on the stressor. There's depressant effects, antidepressant effects, and no effect have been reported. So with this, I'm going to pass you on to Christina, who's going to be talking to you with regards to the behavioral results.
Good morning, everyone. First of all, I'd like to thank Dr. Sammut for allowing me to present with him. Thank you to the sponsors that made it possible for me to be here, and for all of the organizers of the conference for all that you do. So, keep in mind, I'm going to walk you through the results. Afterwards, Dr. Sammut will be talking about the implications. So just keep that in mind. So the first aspect that we're going to look at is body weight. This is shown across the gestation period of the rat. As Dr. Sammut mentioned, it's 21 to 23 days. And we are showing the body weight as a percentage change relative to day 1 of the pregnancy. So as you can see, the rats for the first half of the pregnancy in the full-term pregnant group and the abortion group, they're increasing significantly in body weight in their pregnancy together until the first day of drug administration on day 12. So following the first day of drug administration, the rats in the abortion group begin decreasing significantly in body weight, and they fall significantly below that of the true control group, the non-pregnant rats that receive drug. Keep in mind that the same days that the rats that are receiving drug, the full-term pregnant group that carries their pregnancy to full term, they're receiving vehicle on those exact same days, so that's controlled for. We do see a slight effect in the non-pregnant drug group of the drug administration. However, it's only significant for 1 day in comparison to the several days in the abortion group. So now, something that we're often asked, is the induced abortion the same as a natural miscarriage? And we actually have some results that give us some indication into the answer. We had a small group of rats that were not originally part of this study that naturally miscarried. And we were making measurements on them, and so we were able to compare what does it look like in following a natural pregnancy loss relative to the abortion. Like I mentioned on the other slide, following the drug-induced termination, the rats decreased significantly in body weight. Following the natural miscarriage, we don't see the same result. The rats following the natural pregnancy loss, their body weight basically just stabilizes. They don't have the same significant decrease in body weight as the rats that underwent the medical abortion do. So food intake. How's the food intake affected? Well, we see similar results to that of the body weight. In the abortion group, following drug administration, the rats decreased significantly in food consumption. And for a couple days, they basically eat nothing. Again, we do see a slight effect of the drug itself in the non-pregnant group. However, it's only significant for 2 days in comparison to the several days in the abortion group. What about following natural miscarriage? Comparing that to the abortion. Again, as I just mentioned, following the abortion, the rats decrease significantly in food consumption. Following the natural miscarriage, their food consumption is no different from that of a rat that's carrying their pregnancy to full term. One thing that I want to point out in both of these graphs is that we are taking the body weight into consideration. So the food consumption is shown as a percentage of the rat body weight, given that naturally a larger rat is going to consume more food than a smaller rat. Another thing to take note of is that in this case, we are aligning the days of pregnancy loss. So in the abortion group, this is day 12, the first day of drug administration. We aligned it also with day 12 of the full-term pregnant group to be consistent. For the natural miscarriage group, day 0 is the day of the natural pregnancy loss. Vaginal impedance. As Dr. Sammut mentioned, vaginal impedance is a measure of their fertility. It tells us where they are in their estrous cycle. And we are looking at vaginal impedance pre-breeding and post-breeding. Post-breeding here is referring to roughly 10 weeks post-drug administration week. So interestingly, we see a significant decrease in vaginal impedance, so we could say infertility in a way, following drug administration. Again, this is 10 weeks out, in all of the groups except the rats that carry their pregnancy to full term. So, and there's no significant difference in the pre-impedance level. So pre-breeding, they all start at the same impedance level. So there's some kind of protective effect on fertility of the rats that carry their pregnancy to full term. So now moving on to the specific behavioral parameters. Sucrose consumption, as Dr. Sammut mentioned, is the measure of behavioral despair. One thing that I want to point out is in the following slides, if you hear me refer to treatment week, this is referring to the week of drug and vehicle administration, so the week of the abortion. On the left, we are showing the sucrose consumption as a percentage of their body weight in both cases, during treatment week. So during treatment week, the rats that received the abortion consumed significantly less sucrose than the rats that were non-pregnant and received drug. On the right, this is looking at the sucrose consumption in treatment week, the week of the abortion, and comparing it to the week immediately prior to the abortion. Comparing these 2 weeks, the only group that decreases significantly in their sucrose consumption between the week prior to the abortion and the week of the abortion are the rats that undergo the pregnancy termination. Now, rearings. Again, this is a measure of exploratory behavior when the rats are standing on their hind legs. Within treatment week, the week of the abortion, the rats that undergo the pregnancy termination, they are significantly lower in number of rearings relative to all other treatment groups. And we see similar results, the same result actually, in the other locomotor activity parameters, distance active, percentage time active, and overall speed. We know that these 3 parameters are related very closely mathematically, and so again, we see the same results within the week of the abortion. In all 3 parameters, the rats that undergo the pregnancy termination are significantly lower than all other treatment groups. Now, corner activity, the percentage time that they spend in the various corners of the testing cage. As you'll notice, there's only 3 corners mentioned on the graph. This is because the northwest corner is the corner that the testing bottles are hanging in. So the rats have a difficult time accessing this corner, and across all treatment groups, they spend less than 5% of their time in this corner. So for analysis sake, it was not included. If we look specifically at the abortion group and the amount of time that they spent in the various corners, the rats following pregnancy termination spend significantly more time in the southwest corner of the cage relative to the other 2 corners. So they're spending significantly more time in the far back corner of the cage relative to those 2 front corners. How about the amount of time that all of the groups are spending in that far back corner? Well, the abortion group spends significantly more time in that southwest corner relative to the other 2 groups. Home cage activity. As Dr. Sammut mentioned, this began with subjective observations that the investigators were making. We realized that following the abortion, the rats really weren't taking care of themselves, they weren't grooming themselves, they were huddled in the corner of the cage, and it was behavior that is not typical of a healthy rat. So we recorded their home cage activity 3 days postpartum. So for the abortion group and their non-pregnant controls, the non-pregnant rats that received drug, this is 3 days following the last day of drug administration. For the full-term pregnant group and their non-pregnant controls, this was 3 days post-birth, or the equivalent day in the non-pregnant group. And in home cage activity, following the abortion, the rats spend significantly more time immobile in their home cages relative to the non-pregnant rats that receive drug and the true control group, the non-pregnant rats that receive vehicle. While we don't see a significant difference between the abortion group and the full-term pregnancy group, we propose that this is due to the fact that in the full-term pregnancy group, they have now given birth, they have pups that are 3 days old, they are constantly caring for their pups, they are constantly huddled over them nursing, so at this point, they're really not moving around the cage that much naturally because of the care of their pups. The top image is an example of a rat following pregnancy termination. You can see the hunched posture, the fact that they're in the corner of the cage, as opposed to the bottom image, that is a mother nursing her pups, and that's actually a pup right there. You may also notice that this is under red light. This is because we record their home cage activity in the dark cycle. Rats are not able to see the red light, so we're able to investigate their activity in the dark cycle, as this is the most active time for the rats. So those were the biological and behavioral results. Now moving on to the biochemistry. So as Dr. Sammut mentioned, the HPA axis is involved in controlling a variety of vital bodily functions, especially the significant role that it plays in the control of stress and the stress response. So one way that we can measure the stress is oxidative balance. This is used as a marker of oxidative stress specifically, and it has been altered in situations of stress and depression both in animal models and in humans. We also know that there are decreased antioxidant levels and increased oxidative stress in the blood and brain within animal models of depression. On the other hand, antidepressants have been shown to increase those lowered levels of antioxidants and normalize the stress-induced damage as a result of the depression. So what exactly did we look at? All of the parameters that I'm going to mention, we measured in serum, liver, and brain. And as I'm talking about this, it's summarized in the diagram on the right. So glutathione. Glutathione is an antioxidant. It can be consumed either through an oxidative pathway or a non-oxidative pathway. For the oxidative consumption, it's oxidized to GSSG. This is the oxidized version of glutathione. For the non-oxidative consumption, the glutathione can act as a nucleophile, donate electrons, and this is through glutathionase transferase, or GST. GST is the enzyme that catalyzes that nucleophilic attack on various toxins. This entire dynamic affects both the redox potential and the ratio of GSH to GSSG. The redox potential, a decreased potential, a more negative potential, is indicative of a higher antioxidant capacity. And the GSH to GSSG ratio is an indicator of the overall cellular health. Another aspect that we measured is T-bars. This is through oxidative consumption, the oxidative damage, and it's a byproduct of lipid peroxidation. So just to summarize, GSH is the antioxidant. If it's consumed non-oxidatively, we can measure the GST activity. For the oxidative consumption, we can measure the GSSG. And also for oxidative damage, we measure T-bars. So now I'm going to pass it back on to Dr. Sammut to tell you about the biochemical results.
So, as Christina mentioned, we measured the serum, liver, and brain. Primary effects that we observed are in the serum. The significant differences were in the serum, and those are displayed in these graphs. We basically see a decrease in the GSH-GSSG ratio and an increase in the redox potential in the D+, P- group, that's the group that receives drug, is not pregnant, and also in the pregnant group. Both of these results indicate an increase in oxidative stress. What does this mean? Why is the drug group similar to the pregnant group? So let's look at this carefully from these perspectives, pregnancy and oxidative stress. Oxidative stress can be damaging to pregnancy. It's reported in miscarriages and other pathophysiologies. However, an increase in oxidative stress seems to also be necessary for a healthy pregnancy and also being able to maintain the pregnancy. It's proposed in the literature that the difference in these is a mechanism related to cellular adaptations in the blood that basically offer protection from oxidative stress. So now with regards to drug administration and oxidative stress, we saw that drug administration alone seemed to create effects that were similar to that of the pregnancy group. However, the drug is also having pharmacological effects. And we propose that some of those differences are potentially associated with these pharmacological effects. Mifepristone, specifically, is a glucocorticoid receptor antagonist, and its effects affect cortisol release and ultimately GSH consumption. So it's potentially some mechanism that's taking place through there. That leads me on to the next point, which is oxidative stress and abortion. The abortion group had neither the properties of the pregnant group, nor the properties of the drug administration alone group, which means that what is going on in an abortion is potentially a more complex dynamic that really requires further investigation, which obviously by no means have we finished our investigation. We also conducted some backward regression analyses with the dependent variables being the behavioral parameters and the independent variables being the drug, pregnancy, abortion, and the biochemical measures. However, we created two models. The first model included drug and pregnancy. The second model included drug, pregnancy, and abortion. The main takeaway message here is that abortion played a significant role in being a predictor of all of the dependent variables that we were measuring. At the biochemical level, we see the primary effects in the serum, which is not surprising. However, what is interesting is that there was no variables were basically found to influence the dependent variables that we measured, which indicates that the biotransformation of the drug is potentially not a factor in this. The non-oxidative analysis of the data basically showed us exactly the same kind of thing, similar results. So now I'm going to summarize the results. There's each of these slides, I think there's 3 or 4 here. It summarizes on the left the result that we observed and what it means. Okay, so this is a medically induced abortion, chemically induced abortion, and these are the effects that we observed. We observed a significant decrease, a negative decrease, indicator of negative health effects, in body weight and food intake. These are indicative, according to the NIH, in a reduction in overall well-being in the animal. We observed a significant, actually I should just one step backwards there. I should indicate that if this was the kind of behavior that we observed in an animal that is untreated, that would be cause to remove that animal from the study. However, in this case, what we're observing here is actually a result of what we are doing, of the procedure. We observed a significant reduction in sucrose consumption in treatment week relative to pre-treatment week. This is potentially indicative of an anhedonic effect in accordance with the DSM-5 criteria for depression. We observed a significant reduction in sucrose consumption during treatment week relative to the drug administration group, which indicates that the mechanisms that are taking place in the drug are different from what's going on when we have a drug plus a pregnancy, which results in an abortion. We observe significant negative behavioral changes in terms of the locomotor aspect, distance moved, percentage time active, overall speed and rearings. And this is indicative of potential stress, depression-like behavior. Again, in relation to the DSM-5 criteria. We observe a significant decrease in home cage activity. And again, we relate this aspect to the implication is with regards to its implications with regards to depression-like behavior. We observe a significant decrease in the time spent in the significant increase, in the amount of time spent in the far back corner. Now, I know how this term has come to be used in the secular world, but it's kind of a safe space for the rat, going towards the back, away from the open environment. Remember, if you've ever been unfortunate enough to have mice in your house or anywhere that you've lived, the mice, you never find them in the middle of the room. They go around along the edges because they need to be protected. They need to be away from the open in order not to be exposed to predators. The only rat mouse that you'll find in the middle is either a rat mouse on amphetamine or a rat that's poisoned. So keep those aspects in mind as we talk about this. So this far back corner seems to provide some protective effect, a feeling of protection, which may be reflective of increased anxiety in the rats or anxiety-like behaviors. We observe significant changes in vaginal impedance in all groups except the group that carried the pregnancy to full term. And this is potentially indicative of some protective effects of pregnancy. We're talking about a long time in the life of a rat here. And the fact that the rats, it's only the rats that are pregnant and give birth that show this behavior. It's not the rats that become pregnant and have the abortion. So it's not pregnancy alone, but it's the fact that they carried the pregnancy to full term and gave birth. Interestingly, we have preliminary data now that indicates that rats that undergo an actual miscarriage show more similar behavior to a rat that carries pregnancy to full term than a rat that has had an abortion with regards to vaginal impedance. We're still collecting this data. There's differences in oxidative stress and the oxidative balance, and I've already covered this with regards to its distinction in abortion, that is pregnant, receives drug, relative to drug alone or pregnancy alone. We see significant differences from the natural miscarriage group in terms of body weight and food weight, indicating that there is a significant difference in what's going on in these cases. I just want to point out, one of the questions I'm often asked when I bring up this data is, well, how do you explain depression in humans? The main difference that we need to explain is, when I'm talking about these animal models here, this animal does not have the capacity to contemplate, to reflect on what that life means. We as humans, and we've had a miscarriage, as humans have that capacity. There's that distinction, and that distinction needs to be kept in mind. Here we're talking about purely physiological effects. So, in summary, how does this apply to humans? Well, our results seem to indicate that what we are observing is a moderate to severe stress. And this is comparing it to what the literature has said. This is what it would classify as. It's not a mild stress. We also are seeing, so our abortion-related effects are present several days after the abortion takes place. Most models, all of the models, in fact, that we've investigated with regards to stress-related, depression-related behaviors, see the negative behavioral effects on the same day when the stressor is being applied. We've stopped applying the stressor, the abortion has taken place, and 3 days later we're seeing the maximum effect. Now, I said 3 days. Many of you may be thinking, that's so short term, but this is a rat. Rat time is not human time. When we talk about the effects of food intake, which are clear over at least 7 days, this is the equivalent of approximately 244 human days by some calculations. When we're talking about the biochemical observations observed basically 10 weeks later, we're talking about 6.5 human years. This aspect needs to be kept in mind. So, I was inspired by what you guys inspire me in what you do, and this was not part of the original slideshow, but I included it here because I feel as a basic scientist, I also follow these criteria. I can also follow these criteria. Why am I doing this? If what I'm doing is not useful for our understanding, better understanding of how the human person functions, at the physiological level, after all, God created us physical for a reason. We need to understand the body. If grace, you know, in terms of grace, if that builds on who we are, then we need to understand how we function at the physical level. So I included this here because I wanted to emphasize, I guess, to you that even as a basic scientist, as a neuroscientist, these principles apply to me because what I'm doing applies to humans and how they function. Future direction, and this is basically, we're coming to the end here. I want to administer antidepressants and see whether we reverse the behaviors. I would like to look at the level of the brain doing electrophysiology and electrochemistry and see how the interaction between the upper brain and lower brain changes. Because this corticostriatal, for example, or upper brain, lower brain imbalance is key in our understanding of the dysfunctional changes that take place in the course of psychopathologies. It's informed us in schizophrenia. It's informed us in Parkinson's disease. It's informed us in ADHD. Why can't it inform us here? I would like to investigate further the model, if you want to call it this, of what the work that Dr. Delgado is doing. The reversal of the effects of these drugs. Can we mimic this? What are the differences? What happens? What is going on in the body? What happens in the brain? And potentially I'd like to investigate the late-term termination. However, given how solid I am, and I'm very happy with this model, how solid this model is and how replicating it is, I would like to focus on the mid-term termination, chemically induced termination, and expound in every way possible in our understanding, being at the neurophysiological level, biochemical level, etc. So I would like to now talk about a multitasking mother. She's eating and nursing her babies at the same time. So I would, I'm really grateful to the Watson House Research Institute that made this research possible with their grant. TSC Systems that has donated over $120,000 of equipment. Dr. McMahon, who supported this with more than $5,000 worth of donations, and even including for the purchase of spectral photometer, and other people that have contributed to this research and made it possible. It's a passage to keep in mind from Humana Vitae. And finally, our citations, and I want to give you my contact information. The website, we're in the process of setting up a website for the lab. That it's not yet available. It will be, God willing, in the next few days. And if you'd like a copy of the presentation, I'd be more than happy to email it to you. And thank you so much for your attention.